Hi, and now we're going to do the next topic for chemistry, the periodic table of the elements. A little bit of history about the periodic table. In the mid-1800s, Dmitry Mendeleev, a Russian chemist, arranged the 63 known elements, so those with similar properties were grouped together. So at that time, they only knew about 63 elements, and he took what he could, doing little reactions and little experiments, and looked at what they had in common, those elements, and put them together. And that grouping is how he arranged and made up that periodic table. Mendeleev arranged his elements in rows of 7. So the rows, or how he made his chart, he used that word periodic because it means repeating according to some pattern. Mendeleev's chart is called the periodic table of elements. So periodic, that repeating pattern, it's in a table form, and of course it's arranging all the elements. Now, we take his periodic table, and what we do here is make a modern version, or putting in the elements that we know, all 100 and about 18. In the modern table, elements are arranged by increasing atomic number. Okay, and we'll go over what atomic number is. Okay, but for now, just write down the vocab word. Also, on the modern periodic table, there are groups or families. Columns that go up and down are called groups or families. So that's this way, the way I'm holding my finger, the vertical, have similar properties. The same number of electrons in the last level. So in other words, if you looked at a family or a group that goes this way in the column, they would all have a similar reaction or would not react to certain things if you were to combine them in an experiment, because they have that similar property. If you look at the last level out there where the electron is, that's the indicator that they belong to that same family, and that's why they're in the same column or group. The other way to look at the periodic table is this way, the horizontal. So we're looking at it this way, the way my finger is now. A period is the rows going across. They have the same number of energy levels. Okay? So this way is a period, and that last part of it here, the energy level, there are different levels or positions that electrons are on, and there are the same amount of those levels that the electrons are hanging out on. And again, you need a picture of this, so I will be doing that for you. Blocks. So information about an atom are arranged in what's called a block. Here's an example of a block of an atom, Einsteinium. 99, that's its atomic number. That's how many protons there are. That's how we identify it. Einsteinium, so right here, okay, information. The symbol, Einsteinium, there's a star next to it. That means that it is synthetic. It's also radioactive. This is the name of the element, and 252 is the mass. Notice I skipped this top one here because I just want to go over it since it's a longer list. This is the number of electrons in each energy level that's listed over here. So again, this is how many levels or how many spots there can be starting out from the nucleus. Okay, from the nucleus, and then working our way out, you have these different levels. 2, 8, 18, 32, 29, 8, and 2 are the arrangement for these 1, 2, 3, 4, 5, 6, 7 levels that Einsteinium has. And on each level there's a different arrangement of electrons. Okay. All right, so with that said, we can take the information that is encoded in the periodic table of elements, we can draw a model of the atoms of each element. Okay? So here we have one that's a little bit easier to recognize, magnesium. This right here, again, this is the atomic number of magnesium, 12. This is the symbol. Here's its name, magnesium. And then this atomic mass, 24.305. Right over here, this is going to be where we're going to draw our picture of the atomic model, but based on what's in this square. Okay, so the first thing you need to know is that we're going to need to do a little bit of math, and I've given you this sheet of paper in class. So we're going to go back and forth between the two. All right, so the atomic number is right here, 12. So let's write that in. Let's write that in, 12. Okay, 12. Therefore, there are 12 protons. The atomic mass, remember that's this number right here. This is atomic mass. Okay, I'm just going to round it, though, to the ones place. Notice this is lower than 5, so this will be 24. Atomic mass. To figure out the number of neutrons, I have to subtract atomic mass minus protons, and that will equal how many neutrons? So 24 minus 12 is 12. The last thing to solve for is the electrons. Electrons and protons equal each other if the atom is neutral. So, since our atom here that we're working with is in fact neutral, it will equal the same amount, the same answer, 12. Okay, now that we have all that solved, let's put it into a picture form now. Okay, so I'm going to slide it back and forth so you can see the two. 12 is, again, our number of protons, or our atomic number. I'm going to highlight this one, or just kind of darken it up a little bit for you. This one is not a level. This is the nucleus. So I'm going to put P in here because the protons belong in the nucleus, and there are 12. This right here was the atomic number. This is a combination of protons plus neutrons. Remember, we solved for that and we had to subtract. 24 minus 12 was 12. So there are 12 neutrons. Okay, so one way to show you, I'm going to show you both, the arrangement of the electrons is you could just simply look over here and use the numbers, starting from the inside towards the nucleus. 2, work your way out, 8, and finally on the outside, 2. Okay? And that total equals 12. 2, 8, 2. That's one way we can draw our model. I have a second one done for you here. And in the second one here, notice that I have still drawn or written out the number form for protons as 12, neutrons as 12, and I highlighted where the nucleus is. These are the different levels. Starting from the inside, I drew 2, then I did 8, and then I put 2. Either way is correct. The last thing to tell you is a rule, okay? Just so you know. There are rules for placing electrons in the electron cloud. Only 2 electrons can fit in the first level. Only 8 electrons can fit in the second level. And only 18 electrons can fit in the third level. Then it gets really complicated. So for our class, we're going to just work with these first 3 levels. Or, if it gets bigger, I will do, like we had for the Einsteinium, I will give you the list of all the electrons and just tell you the numbers, so you don't have to solve for anything. Okay, thank you for your attention. If you have any questions, you can find me, and I'll be glad to help you.